Hello everyone. For today's tutorial video, I would like to discuss how to analyze a trapezoid, including how it can only be one of two types, isosceles trapezoids or right trapezoids, as well as prove the area formula is the same even though the two types of trapezoids look very different. Geometrically, a trapezoid is defined as a four-sided shape with only two of its sides parallel and the other two not. Usually, when you hear the word trapezoid, the isosceles trapezoid is what comes to mind first, as it is a trapezoid made up of a rectangle and two right triangles that add up to make an isosceles triangle. Because of the way the trapezoid is made up specifically of a rectangle and two right triangles, we first plug in the area formulas for these individual areas, which in this case will be, for the left triangle, height of trapezoid times 1/2 times length of left triangle. And for the right triangle, we use the same formula, except the length is the length of the right triangle instead. Although that detail technically does not matter, because the triangles both have the same length. We finally calculate the area of the rectangle by trapezoid height times length of rectangle, and our areas have now been written explicitly. However, we can also simplify this by noticing the identical factor of trapezoid height in all three areas, as well as the identical factor of 1/2 in the two triangles. So the formula is now 1/2 times height times, in parentheses, length of left triangle plus length of right triangle plus 2 times the length of the rectangle, because if you divide 1 by 1/2, it is the same as multiplying by 2. With some creativity, we can see that the length of the triangles plus 2 times the length of the rectangle is simply the length of the bottom half of the trapezoid plus the length of the top half of the trapezoid. So this means the formula, in its most simplest form, would be 1/2 times height times the sum of length of bottom half of trapezoid plus length of top half of trapezoid. Although we have proven rigorously that this works for an isosceles trapezoid, we must remember that in the study of geometry, things must be proven explicitly on a case-by-case basis. We cannot make assumptions on anything. So for a right trapezoid, it is a trapezoid with two right angles, and only one triangle as opposed to two. This shape is not what you commonly think of when you hear the word trapezoid, but can still be seen applied in some scenarios, such as half a picket fence. We can see the area of it is a sum of the area of the one triangle and the one rectangle, and the area of the triangle is 1/2 times the length of the trapezoid plus the height of the triangle. And by similar reasoning, the rectangle is the length of the trapezoid times the height of the rectangle. We sum these and notice the common factor of the length of the trapezoid. So we now see the area is 1/2 times the height of the right triangle plus the height of the rectangle, all multiplied by the common factor of length, which is isolated. And we can again see a creative trick similar to the isosceles trapezoid, namely that the height of the right triangle plus the height of the rectangle equals the height of the right side of the trapezoid, and that the height of the rectangle alone equals the height of the left side of the trapezoid, so that the height of the trapezoid equals the height of the short end plus the height of the long end, divided by 2, exactly like with the isosceles trapezoid. And the length of the trapezoid is the same throughout, just like the height of the isosceles trapezoid. So our final answer for the area of the right trapezoid is height of long end plus height of short end all over 2, and times the common factor of length, which was the exact same formula as for the isosceles trapezoid. Just like the perimeter breakdown of the previous shapes, we can see that the perimeter of a right trapezoid or an isosceles trapezoid is nothing more than the perimeter of the shapes that make it up, minus the lengths that are inside the shape. So minus the length of the intersection between the left triangle and the rectangle, and the intersection between the right triangle and the rectangle, in the case of an isosceles trapezoid. And for a right trapezoid, we would subtract the one and only line that is not on the perimeter of the shape, in this case, the line that is the intersection between the one right triangle and the rectangle. But all the other lines on the shape would constitute the perimeter. And in both cases, we would use the Pythagorean theorem as necessary, where the lines slant. Now that I've rigorously proved all of the area and perimeter formulas for triangles and basic four-sided shapes, we can move on to shapes that have greater than four sides, starting with the simplest types, which are called regular polygons, owing to how it has equal angles and equal sides throughout it, and how, as long as the polygon is regular, there is a special formula you can derive to find the area and perimeter of it. Don't forget to subscribe if you found this video informative, and make sure to see the other tutorial videos, and follow me on either Facebook or Twitter for more content.